All right, so we're going to begin today's section of notes on writing equivalent radical expressions. So it's basically doing factor trees, kind of like a greatest common factor situation, but in this case, we're looking for pairs of the same number. So for example, if we take the square root of 4, that breaks up into 2 and 2, that's a pair of 2's. So I like to refer to the radical in this case as a house. In that, in order for you to leave the house, you have to have a friend, like an exact friend, to leave with you. So in this case, the 2's are friends, and so they leave. But they like to be in pairs. They don't like to be in odd numbers. So no third wheels happening here. Okay? So let's do an example A, 1A. Now, this is not the square root of 4. This is actually not a perfect square at all. So instead, I'm going to break up 63 into something times something. So what times what gives me 63? I usually like to start with evens. 63 is not an even number, it's an odd number. So let's see if we can divide it by 3. So I see that 63 divided by 3 is actually 21. So I'm going to do 3 and 21. Now 3 is a prime number, so I'm going to leave it. I'm going to move on to 21. That's not a prime number. So what times what gives me 21? Oh, I have a 3 and a 7. Okay, so now we have to look for pairs. Are there any pairs that I can have leave the house? I see these 2 3's. They are the exact same, so we are going to let them leave. So the 3 is going to stay on the outside of the radical, and then we're going to put the house, and then what's left over is the 7. So that 7, since it's left over, it's going to stay inside the house. So the square root of 63 is equivalent to 3 root 7.